Math students, here's video 2 for Unit 6, Lesson 1 sets. And I wanted to make one quick correction. I think in letter C I had mentioned in the last video, unfortunately, I said that there were only, I think it was 2 folks who were taking both math and science. But this actually, if I remember right, it's going to be 3. So you got Ashley. Ashley's taking both math and science. Then if you look at Chris, and that's the one I think I left off, he's taking math and science. He happens to be taking language arts as well, but he's definitely taking math and science. And then I think if you look down, you've got Eater here. Eater is taking math and science. So who would that be? That's taking both math and science. That would be Ashley, Chris, and then of course Eater. And I think I left Chris off on the last video, so I wanted to make sure I went back and corrected that. Correct that on your own paper as well if you're following along at home, okay? So that would be Ashley, Chris, and Eater. And I left Chris off. He was in the middle there, but he actually is taking both math and science. So make sure we make that correction. Let's come on down. Let's look at number 3, which is the one we had left off on last time. A manager that owns 3 local area car maintenance garages was researching certifications of mechanics that worked for her company. Consider the following Venn diagram. How many mechanics worked for her company? Well, we just want the total number of mechanics that are in the sample space in all. So I would just count up all these numbers. 4, let's see, 5, 7, 9, 12, 15, 3, that's 18. So I've got 18 that are working for her company. All right, so now how many of the mechanics are certified by ASE to do work on brakes? Well, that's everybody who's in the brake circle here. So that's 4, 2, 6, 8, 1, that's 9. There are 9 mechanics ASE certified to do brake work. How many of the mechanics are certified by ASE to do work on brakes and tune-ups? So that's going to be folks who are not only in the brake circle, but they're also in the tune-up circle. So they're in this intersection here. And that's going to be 2 plus 2, that's 4. We've got 4 guys. We've got this one, these 2 here, and then we got these 2 who are certified in all 3. They could do brakes and engine tune-up work. How many of the mechanics are certified by the ASE to do work on either AC, air conditioning, or tune-ups? So they could do AC or tune-ups. Well, how many folks are in the AC group? Well, that's 2, 3, that's 5, 6. And then we got another 5 down here who could do tune-ups. So we've got 6 who can do AC work. We've got 6 here. And then we also got another 5 down here who can do some tune-up work. So that's 11 folks who can do either AC or tune-ups. If I need someone who can do an AC or a tune-up job, I've got 11 folks. And there's 2 that could do both. All right. In fact, they can do all 3. How many of the mechanics have their certification in brakes or AC, but not in tune-ups? Meaning they're in the brakes and AC group, but they are not certified in the tune-ups. That's 8, right? That's these 8 folks up here that are not in the tune-ups group. So we're going to put 8 here. And then, actually, I think that takes care of it for us, because the next question we're going to work on deals with a high school sports program. So take a look here. Make sure you're okay. Take a look at number 4. It says the following Venn diagram shows a breakdown of a small high school sports program. How many students in the sports program? So sports programs here, and then we've got all the other students here that don't play in this small sports program. How many students play only tennis? Well, that's the folks down here. These folks play tennis, right? These folks here play tennis, don't play anything else. So that's going to be 14. We've got 14 individuals in this high school sports program that play tennis. How many students play basketball and tennis? Well, that's going to be the intersection between the basketball group and the tennis group. Well, we've got 5 athletes here who play both basketball and tennis. Now, how many students play basketball or baseball/softball? So how many students play either basketball or they're in this circle over here with the baseball/softball group? Well, I've got to do some counting here. So I've got to do, let's see, 12 plus 8 plus 20, that's 40. And then I've got 2, 3, and 2, that's 47. That's most of the program. They either play in this circle or that circle, or it could be both. Could be both. Now, how many students play baseball/softball or tennis, but not basketball? Meaning they're in this circle, Or they're in this circle, but they're definitely not a part of this circle. Well, that's these folks. See if I can highlight this. That's these folks right down here. These folks here play baseball or softball or tennis, but they don't play basketball. That looks like that's 28 athletes. Okay, 28 athletes. Now, how many students that play a sport do not play basketball? So how many students who play a sport do not play basketball? Really the same question as the question we had before, right? So how many students play a sport, do not play basketball? What's these people here? It's these people here. So 12 plus 2 is 14 plus 14, that's 28. 28 students. All right. Keep in mind, I'm saying that these students here, they're not a part of the sports program at all. It's a small high school sports program. They only have 3 sports going on. Now, how many students attend this school in general? Well, that means we need to add up all of these students plus the students who are not playing sports. So we got this group here, 552, plus all these folks in here. So let's see, 12, 8, 20, 40. I think here we said was 47, plus another 14. I think that's 61 plus the 552. We have 613 students at the school. So we have 613. That's just your total. That's your total right here, okay? 613. That's adding up all the students who play sports and the students who don't play sports. And then it says, how many students do not play tennis in total? How many students do not play tennis? Well, that's going to be the students who are up here that are not included in this tennis circle. So 12 plus 8 is 20, plus another 20, that's 40. Another large percentage of the program, they don't play tennis in total at all. Let's see if I can get rid of that box. There we go. So 40 students do not play tennis in total. If you need to, go back and look at this Venn diagram. I recommend you look at the worksheet, the task, and make sure you can find these values on your own through this Venn diagram. Now, let's take a look at number 5. In the state of Oregon, all of the area codes start with a number greater than 4 and end in an odd number. So number greater than 4, that's going to be important to keep in mind, and they end in an odd number. All right? So notice here, 5, 3, 9, 1. So 5 and 9 are both greater than 4. 3 and 1 are both odd. So let A represent the set of all area codes that start with an even number, and let B represent the set of all area codes. And set A represents the set of all area codes that start with an even number, and B represents the set of all area codes that could be used in Oregon, meaning they start with a number greater than 4 and they end in an odd number. Sit down and think about those for a second. See if you can answer these next 3 questions. All right, I hope you've had a second to think about that. Hope you paused the video, tried to answer those questions. Here are the correct answers. Which one might be an area code that belongs to both set A, starts with an even number, and set B? Well, that's going to have to be letter D. Okay, bigger than 4, end is in an odd number, 6 is even. Fantastic. Which might be an area code that belongs to starting with an even number and doesn't fulfill the Oregon standards? Okay, starts with an even number and doesn't fulfill the Oregon standards. Well, that would be A. 4 is not greater than 4. So that doesn't fulfill the Oregon requirements. What might be an area code that belongs to the set not A and not B? Meaning doesn't start with an even number and doesn't fulfill the Oregon requirements. Okay, doesn't start with an even number and doesn't, fulfill the Oregon requirements. Well, this one right here is going to be a problem, right? This one doesn't start off even, so it doesn't fulfill the requirements of A. And then also, because of that, it sort of messes up the whole thing. We're not going to fulfill this and, this intersection of both, because this guy right here does not fulfill the requirements of starting with an even number. All right. If you notice, the other ones do start with an even number. I'm also noticing a typo on this one. This one right here should be a 2. That should be a 2 right there. There we go. Got that corrected. That way it's not B, because otherwise that would have fulfilled the requirements of B. So now this 792, that does not fulfill the requirements of A because we start with an odd number, and we don't fulfill the requirements of Oregon. because we end in an even number. I was wondering why that was messed up, but that should be a 792 there, 792. All right, let's look at these license plates. In a particular state, the first character on a license plate is always a letter. The last character is always a digit from 0 to 9. Let V represent the set of all license plates beginning with a vowel, and O represents the set of all license plates that end with an odd number. All right, which might be a license plate that belongs to the set V, starts with a vowel, and O ends with an odd number. Well, I think that one's right here. Starts with an A, that's a vowel, and 9, that's an odd number. Now, which license plate belongs to the set V, starts with a vowel, and not O, meaning not an odd number? Starts with a vowel, ends with an even number. That would have to be this one right here. Now, which one might be a license plate that begins with the set not vowel and not odd, meaning we start with a consonant and we end with an even number? So it can't be this guy. That starts with a vowel. That starts with a vowel. This one ends with an odd number. So it's got to be this guy over here. We start with a consonant, letter P, and we end with a not odd number. That's number 6, which is an even number. I hope this helps you guys out. There's a few more available here if you'd like to practice and follow along with these problems to nail down our introduction to probability. There's also a classwork posted for you on our classwork and assignments page. Good luck, and let me know via email or remind if you have any additional questions. Thanks, geometry students.